Hi everyone, this is the last problem of section 7.4 where we have to find the volume of a parallelepiped whose three edges are given by the vector A, 3I plus J plus 1 and then B like 1, 4, 1 and C 1, 1, 5. And here we have to find the volume of this parallelepiped. So the formula to do that is first let's find the area of it. So to find the area of it, it is simply B cross product with C, because you see here it is like the area of the base. So this base, so the area of this base is the cross product of B cross C. So this. Now, since it looks like a rectangular prism, and rectangular prism, if you want to find the volume of it, it is area times height. So, since this is a triple scalar product, so this can be written as A dot product with B cross C. So this will give us the volume of this parallelepiped. So this is the formula that you need to know. So if you guys want to visualize it, so this A, you see, this is the height. So this is the height, and B cross C, this is the base, the area of the base. So area times height gives us the volume. Okay, so just remember this formula. Now let's do a problem of this. Okay, so like I said, the formula is simply A dot product with B cross C, but this is simply the determinant of these vectors, so determinant of 3 by 3 matrix. So let's set up the matrix. I'm gonna write the formula at the top just so I don't run out of space. Now, okay, 3, 1, 1, and then this here in the first column my vector A goes, and then vector B and vector C, and make sure to write these in order, like uh, in the first column vector A, and then the second one vector B, and in the third one the vector C. Otherwise you will not get the right answer if you don't put them in the order. So 1, 4, 1, and then the vector C 1, 1, 5. You see, right? Because these can be written as like 3, 1, 1, and 1, 4, 1, and 1, 1, 5. So these are the vectors that I wrote here: 3, 1, 1, 1, 4, 1, and 1, 1, 5. Okay, now let's move on to the next step now. For that, we'll need to cross the first row and first column. So we cross first row and first column. So we're left with this. So let's write it: 4, 1, 1, 5. And what is the number that is in front? So like this one, the first number in the first row, this is 3. So we write 3 in here. Next, we have to put a negative here because the signs alternate, like positive, negative, and then positive. Now, and just so you don't forget, we can write it in at the top as well, like positive, negative, positive. So we know like this has to be positive 3, and this has to be negative 1, and then the next one has to be positive 1. So now let's cross out the rows and columns. So now crossing out the second column and the first row, we're left with this. So we're gonna put it in here: 1, 1, 1, 5. Now crossing out the third row and the first column, crossing out the third row and first column. So we have 1 4 1 1. What is left? Like 1 4 1 1. Okay, so do you guys get it? Like here, the first number in the first row is 3, and then the next one has to be negative. So this is 1, so but it has to be negative, so that's why you put -1. And here it's 1, so 1, and crossing out the rows and columns, so what is left with goes inside it. Now we have to solve this 2 by 2 matrix, and for that we go in this direction, so 4 times 5, but we have a 3 here, so we're going to multiply it by that 3. So writing 3 times and then 4 times 5, which is 20, and then we go in the other direction, but when we go in the other direction we have to put a negative, so putting a negative and then going in the other direction, so like 1 times 1, which is a 1. Now moving on to this one, it's multiplying by -1, so we write -1, and then 1 times 5, which is 5. And remember, when we go in the other direction, we have to put a negative. So negative, and then multiplying in the other direction. So like 1 times 1, which is a 1. Now +1, because it says in here +1, and then we have to do 1 times 1, so which is 1, and then going in the other direction, first what do? Put a negative, yeah, and then go. So like 1 times 4 is 4. Now let's just simplify this. So then this is 19, -1 times 4, then plus 1 times -3. And if you multiply it, you will get 57 minus 4 minus 3, and this gives 50. So 50 is the volume of the parallelepiped. This is kind of an extra part of this video, but I just wanted to show it to you guys that we can find the determinant using a simpler method as well if you guys want to use it. So let me just show you guys quickly. So we have this determinant. So what do is, right, we repeat these 2 rows. So let's just do that. So repeat these 2 rows, like these 2 columns, I mean. Okay, so then 4 1. So what I did, I just rewrote them. So like 3 1 1 3 1 1 1 4 1 1 4 1. Now what do is we're gonna multiply these and we just write the multiplication of these, like 3 times 5, 3 times 4 times 5 gives us 60. So write 60, and then we have 1 times 1 times 1, which is 1. So you write +1, and then next we have 1 times 1 times 1. So again we have a +1, and then you go in the other direction, and like the 2 by 2 matrix, if you go in the other direction you will put a negative. So you'll put a negative and you'll put the braces, and then you go in the other direction. Okay, let me use the other color for that. Okay, now we go like this. So you just like follow the arrows where it's taking you. So now we're gonna multiply these. So like 1 times 4 times 1, what does it give? It gives 4. And then I'm gonna add that to 1 times 1 times 3, which gives 3. Now add 5 times 1 times 1, which is 5. Now adding all these together gives us 62 here. And here we have 4 plus 3 plus 5. So we have 12, and 62 minus 12, which is 50. So you see, we got the same answer as using the previous method, but I just find this method quicker. So if you guys want to use this, you're free to use it. But if you're comfortable with the other method, you can use it as well. I was just showing you guys, so like it might be easier for you. Okay, so that was it for today's video. Thanks for watching.